Hello, Algebra 1 students, and welcome back to Topic 8, our polynomial operations and factoring. We're finally on the downhill slope of things. We only have a couple lessons left, 3 total lessons left, and some good news today. You're not actually learning too much. It's really a practice day with maybe 1 or 2 connections to what we've done in the past, but I hope it is not too terrible of a lesson. So let's get to it. Last class, we kind of broke down factoring a trinomial, right? We had this ax squared plus bx plus c. We broke it down into 2 separate parts, and it kind of looked like a lot of steps. Well, today we're just going to do the whole thing in one fell swoop and make sure we understand what work should be shown, if you even need to show work, and then we'll make a couple connections, and that's about it. So let's get to it. You should have a riddle in front of you on the first page, and I went ahead and rotated it on this side. Your goal is to put each of these guys into factored form, right? So factored form looks something like this. Okay? And then once you figure out the factors, you're going to cross out the 2 boxes down below. It's always good to cite our sources. This is from Algebra with Pizzazz. This is pretty old at this point. I bet it's probably 20 or so years old, but it works just fine. So to put this into factored form, you could guess and check. However, on most of these, I probably wouldn't guess and check, right? 6, you'd have 6x and x, or it could be 3x and 2x, and then you'd have to guess for the 3's, and maybe this one isn't too terrible, but it's not my favorite either. So instead of guessing and checking, we're going to really practice that box method just to show you how it works so well. So our first problem, 6x squared plus 19x plus 3, I'm going to do down here. So we have problem 1, 6x squared plus 19x plus 3, and we're going to see what we can do for turning this into factored form. Okay. And if you remember, the first step is we build that box, and we fit in what we can so far, 6x squared and 3. Then I need to split up this 19x. So I need 2 numbers that add to make 19x's. And, so the 19 came from over here. And this is the tricky part that a lot of people forget, these diagonals of our rectangular box have to multiply to equal the same number. So this 6x squared times 3, which is 18x squared, is going to be the same answer as when I multiply these guys, these blanks right here. So if you have your factoring sheet, the easy way to do it is to look up the 18. We always start with the multiplication first, and think what multiplies to make 18. So on your factoring sheet, you'll see that's 1 times 18. It is 2 times 9, and 3 times 6, and I think that's it. You have 3 options here. Out of those 3 options, which ones add up to make 19x? Well, hopefully you're looking at that saying, well, it's got to be 1 and 18, and you're correct. 1x and 18x adds to make 19, and 1x times 18x multiplies to make 18x squared. So 1x, 18x, any order is okay. And now we find the outside of the box. Okay. 6x squared and 1x just have an x in common. And 18x squared and, or 6x squared and 18x have a 6x. X times 6x is 6x squared. X times 1 is 1x. 6x times 3. 3 times 1 is 3. And there's our factored form. 6x plus 1 and x plus 3. So notice there are actually not a lot of steps you need to show here. I showed the inside of the box, and I showed my 2 steps, what added, what multiplied, and then found the outside. 6x plus 1, x plus 3. You remember that? I'll put it over here too. It was 6x plus 1 times x plus 3. Let's see if these are down here and see if we can cross them out. 6x plus 1 and x plus 3. Where is that guy? Looking. There it is. Perfect. All right, now that you've had one example of how to do this box method again, why don't you guys go ahead and try and tackle these other 9 or so problems. Depending on the time, you might not have enough time to finish all of them, but you should be able to make a good dent. We need to do a lot with problems where you have to factor, and actually, unfortunately, factoring is just the beginning of these problems. There's a lot more we're going to do, especially when we get into graphing and solving. So try these 9. The more you practice, the better you're going to get. See if you have enough time to figure out the hidden message. If you don't, that's okay. And then once your teacher moves you on, you can unpause this video and skip down to the third page. Ready, set, go. All right, you're back. So we're jumping down to that third page. Now, this third page is actually a blast from the past. In something like lesson 8.06, we first started to learn how to factor with just a greatest common factor. So we didn't actually go through and do the whole box method, right? We didn't go through and write this with two sets of parentheses like this at the end. What we did is we learned two ways to set these up. We said, okay, we're just going to look at each individual term and ask ourselves, do they have anything in common? Right? Or do these have anything in common? And what we learned is two different methods to do that. One method is we just called it the undistributive property, and we said we're going to undistribute something and put it out front. The other method was kind of like a miniature or easier box method. And we're actually going to do that easier box method with each of these three. And then once we're done with that, we're going to explain how this ties into the full box method that we've been doing, because it's really going to be kind of that two-part process. So let's go ahead and get started with x squared plus 6x. So x squared plus 6x, what we did before was something like this. We said, okay, x squared plus 6x, there's only two terms, x squared and 6x. And in fact, I encourage my students, instead of x squared, to write x times x. Then we only have three sides, the left side and then two spots in the top. So to figure out that left side, we say, what do these two have in common? Well, it looks to me like they each have an x. So I actually like to go through and cross out the x's and say we factored out that common x. Well, what's left? Well, there's still an x that's left and a 6. So the factored form of x squared plus 6x is actually x times x plus 6. In fact, I usually suggest that factored form is when you can write two or more sets of parentheses where each set of parentheses has a variable in it. So this is a pretty good factored form. In fact, this looks a lot like what we did on the previous couple lessons if you add an extra 0 in with that x. Right? X plus 0 is the same as x, and this should be familiar as factored form. So let's try our next one. Yeah? So we're going to go through, and we'll need a 3 by 1 box this time. Okay, 2x to the fourth. Well, x to the fourth, 1, 2, 3, 4. 3x cubed, and x. Now, we also do have these coefficients out front. There's that invisible 1 there if you want. And it is possible to divide a common factor out of those coefficients. But if you look at your factor sheet and look at 2, 3, and 1 all at the same time, they don't have anything in common besides 1. And we don't need to factor out a 1. So I'm not going to take a number out, but I am going to take out some x's because I think they each have an x in common. Let's see what that leaves us. Still a 2, and then there's 1, 2, 3 x's, so x cubed. 3x squared, and just 1. You can always double check. X times 2x cubed is 2x to the fourth, and so on and so forth. So my fully factored form here is x times 2x cubed plus 3x squared and a positive 1. Last one. There we go. 5x to the fifth. And you don't have to write your x's this way. I just prefer it. I think it's a nice little visual. There we go. And 20x squared. Okay. Well, let's start with the x's. Those are pretty easy. It looks like they each have two x's in common. So I'm going to take those two x's out. Two x's in common is x squared, x times x. And what's left over? Well, x, there's going to be an x cubed. There's going to be an x and nothing left there. But then what about 5, 15, and 20? Right, if you check that factor sheet, 5 is 1 times 5. 15 has 1 times 15, but also 5 times 3. And then 20 has quite a few factors, right? 1 times 20, and then we have 2 times 10, and 4 times 5. Now looking at these, do they have anything in common? Well, I mean, clearly they have a 1 in common, but I think they also all have a 5 in common. And since they have a 5 in common, I'm going to divide out a 5 from each of those. Then we play the game. 5 times what gets you 5? Well, that's a 1. 5 times what gets you 15? That's 3. And 5 times what gets you 20? That's 4. Right? You notice it's the number that the 5 is attached to. 1, 3, and 4. We get those numbers up top. And so my final factored form here would be 5x squared times 1x cubed plus 3x plus 4. Now, why are we going back to this? This seems kind of weird. Well, we can actually put this concept together with the box method, and sometimes we have to do that, right? On problem 5 and problem 6, you might have discovered that your answers didn't match anything that was given to you down at the bottom. And we're going to try to show why. Now imagine you were asked to factor 30x squared minus 50x minus 20. Okay, you might be tempted to start by using the box method. Okay, well, the box method, though, is going to be a little bit trickier, and I'm going to kind of put this box right over here and show you why. We would have 30x squared and negative 20, and then we'd have to find what goes in these two last spaces, of course, right? And so we'd say, well, the two numbers are going to add up to be this middle term, negative 50x, and then they're going to multiply to equal the other diagonal. The other diagonal, though, is 30x squared times negative 20. And 30x squared times negative 20 is negative 600x squared. Your factor sheet doesn't go up to 600. In fact, 600 has a lot of factors, and I would not want to take the time to find all of those factors, right? We'd have to go through and see which one adds up to negative 50, and you do 1 times 600, 2 times 300, 3 times 200, 4 times, and so on and so forth, right? There's going to be like 20 factors there. Maybe there's only 10 or so, but there's a lot of factors. I don't want to list all those out. So is there a way to make this easier? And yes, there is. Before I go through and do this box method, I'm actually going to look for a greatest common factor that I can divide out of all three of these terms. So I guess I should go back and fill in the step above. When you do ax squared times c, that's the diagonal here, you get negative 600x squared. So instead, for our first step, we are going to take out the greatest common factor. And here's how we do it. You can use the box method, or if you don't want to do the box method, you totally don't have to. We're going to end up really doing the box method twice, and I'm going to show it over here quickly. All right, so I'll just do a little arrow, and something like this I think will be okay. We have three terms in here, 30x squared, negative 50x, and negative 20. Now notice that they don't all have x's. There's no x over here. So because there's no x over here, we can't take out any x's. That means there'll be an x squared and an x. However, 30, 50, and 20 all have something in common. Take a look at your factor sheet and see if you can determine what they do all have in common. And hopefully it jumped out at you because they all end in 0, that they have a 10 in common. So I'm going to divide out a 10 first. Then we play that game. 10 times what is 30? 10 times 3 is 30. 10 times what is negative 50? Well, it's negative 5. And this one will, of course, be negative. Whoops, of course, and then I get it wrong. Negative 2. So what I did here is I actually went through and rewrote this as 10 times 3x squared minus 5x minus 2. Now this 10 that's on the outside isn't actually going to affect anything at all. That 10 is just a constant number. It's not going to affect my final answer. So now I'm going to do the box method, but just with the part that I'm highlighting in orange. And I'll show you what the answer looks like at the very end. I have just enough space over here. But we're just going to focus on that orange section. I'm going to go ahead and cross this off so you don't think I'm doing anything here. Let's do the box method quickly. All right, so box method wise, we have our 3x squared and negative 2, right? I'm just focusing on this orange part. We need to find two numbers that add to equal negative 5x, that's the part in the middle, and they have to multiply to equal this other diagonal. 3x squared times negative 2 is negative 6x squared. Focus on the multiplication. What multiplies to make 6 and adds to make 5? I think it's going to be 6 and 1 in this case. This one's actually pretty tricky. A lot of students mess it up and they think it's going to be 2 and 3, but it ends up not working out. Trust me on that, I hope. So yeah, I think it's going to be negative 6x and 1x. Negative 6 plus 1 is negative 5. It multiplies, yeah. So negative 6x and 1x. I'll erase this just so it doesn't get too messy. Let's figure out the outsides. 3x squared and negative 6x each have a 3 in common and an x. 3x times x is 3x squared, negative 2, and 1. Bonus box, is 1 times negative 2 negative 2? Yes, it is. So I was able to factor this into 3x with a positive 1 and an x minus 2. Now, notice that there is still a 10 here. The 10 has not gone anywhere. The 10 still sits out front. And you can put it in parentheses or not. It doesn't make a difference. Most people would not waste the extra parentheses there. But this is our fully factored form. Now, let's say that you didn't realize you could take a 10 out of there. And you kind of brute forced it and you figured out the answer, right? Let's say you didn't divide the 10. And instead, you said that 30x squared minus 50x minus 20 was either, and I'm taking these from this problem right here, 30x plus 10 times x minus 2, or you said it was 3x plus 1 times 10x minus 20. Now, you'll find that both of these are correct answers. However, they don't look exactly the same as our answer up above, do they? But you might notice something. You might notice that in this first set of parentheses, this 30x and 10, don't 30 and 10 have something in common? Couldn't you factor or divide out what they have in common? What do they have in common? It looks like they have a 10 in common. That would chop off a 0, chop off a 0. That'd give me 10 times 3x plus 1 times x minus 2. Oh, well, that is exactly what our answer was. Or what about if you had this over here? 3x plus 1 has nothing in common, but 10x minus 20 does. That has a 10. And so you can factor out the 10, and that would give you 3x plus 1. The 10 would be factored out, and then that would chop off a 0. That'd leave you with x minus 2, which is again the same. They moved the 10 to the middle instead of the front, but it is still the same idea. So if you don't realize you can divide something out, you can still get the right answer. Okay? And I'm going to show you how we can do that with a problem down below. Okay? This problem down below, you might look at it and go, oh, well, I can factor that. It's the box method. And you're right. Okay? So let's go ahead and just try the box method. You can tune me out and do it on your own if you'd like. So got this. 3x squared, negative 36. All right, well, we need a couple things here. It looks like we need two numbers that will split up the negative 3x that's right here. But also, we're going to need those same two numbers to multiply to equal the product of these diagonals here. It's kind of a big number. It could be rough. 3 times 36, that's 18. I think it's negative 108. You might want to use a calculator for this one because there's a lot of factors of 108, I think. I'm going to try to do it just mental math-wise, and that'll give you guys a chance to catch up with the calculator. But if we look at 108, here are our factors. And it's not on a factor sheet, so it's good to be able to do that without the factor sheet, too. Make sure you can use a calculator. It could be 1 times 108. I know 108 is even, so it could be 2 times, that looks like 54. We could, 1 plus 8 is 9. 3 goes into 9, so 3 will go into this. 3 goes into 10 3 times, and then 18 is 6. There we go. 4 goes into this because the last two digits are divisible by 4. 4 goes into 8. So 4 goes into 10 twice. 2 left over is 27. 5 doesn't go in. Does 6 go in? I think because 3 and 2 both go in. I think 6 goes in as well. 6 goes into 10 once with 4 left over, 6 and 18. Notice these numbers are getting closer together, so I don't have too many more to go. I don't think 7 goes in. 7 goes into 10 once. 3 left over, doesn't go into 38. Does 8 go in? Well, 4 and 2 both go in, so I bet 8 goes in. 8 goes into 10 once. 2 left over. Nope, 8 doesn't go in nicely. If you tried 108 divided by 8, I think it will not work out well. Yeah, So 8 didn't work, but I know 9 goes in because 9 times 12 is 108. No 10, no 11. There we go. Okay, 1, 2, 3, 4, 5, 6 factors. Woof, it's a bunch. Okay, so we have 6 factors, and we need to find the ones that are 3 apart. Those aren't 3 apart, 3 apart, 3 apart, 3 apart, 3 apart. 9 and 12, those are 3 apart. I think these are going to be 9x and 12x with probably a negative here. Which one has to be negative? I think the 12 has to be negative. 9 minus 12 is negative 3. Yeah, okay. So we have 9x and negative 12x. Let's factor this so we can be done with it. 3x squared and 9x each have a 3 and an x. 3x times x is 3x squared. 3x times 3 is 9x. X times negative 12 is negative 12x squared, and bonus box works out okay. Now, notice for this one, you actually could have done this and gotten a slightly different answer, right? The answer I got was 3x minus 12 times x plus 3. However, what if instead of starting with this left one, you started with the top one? 3x squared and 12x have a 3x in common, and that would give you 3x times x. This would be a negative 4, and this would be a 9. So my other option would be 3x plus 9 times x minus 4. That's weird. We got something different. That's never happened with our box method before. Well, what's really happening is you'll notice, maybe, that in this first set of parentheses, there is a common factor of 3. We could divide a 3 out from both. And there's a common factor of 3. What that means then is on part B, we could have actually made this easier for us. We could have said, oh, there's a common factor of 3 in all of these. We can divide everything by 3. So I would go and I would factor out a 3. And again, you could use the box or you could use this undistributive property. I'm basically dividing out a 3 from all of these. That's going to leave me with 1x squared minus 1x minus 12. Do you see that if you multiply the 3 back in, we would get what we started with? And so what I'm actually going to do here is I'm going to factor. I'm going to leave the 3 alone, and I'm just going to factor this part in blue, and it's going to take up these 2 parentheses. To do that, I'll jump into my box method again. Right? If we look at this box method here, I'll actually give a little more room over here. We have that x squared and negative 12. I need to split up the negative 1x, so I know my 2 values will add to equal negative 1x, and they're going to multiply to equal the product of this column, of this diagonal, negative 12x squared. So what multiplies to make 12 adds to make 1. Look at that factor sheet again. 1 times 12, 2 times 6, 3 times 4. Which factors are 1 apart? 3 and 4 are 1 apart. So I think this will end up being some combination of 3x and 4x. Because they're multiplying to make a negative, we only need to make one of them negative, and I think that'll be the 4, the larger one. So we get 3x and negative 4x. What do x squared and 3x have in common? Just an x. X times x is x squared. This will be a 3. This is a negative 4. Bonus box checks out. So what I actually did is I factored this into x plus 3 and x minus 4. Something like so. Now you'll notice that that is actually the exact same thing as either of these. It may look different, but if you distribute the 3 to the x plus 3, you would get 3x plus 9. Or if you distributed the 3 to the x and the minus 4, you'd get 3x minus 12. Now, which of these answers is right? Well, they're all correct. However, if this was a multiple choice exam, which answer would be presented for you? It would definitely be this guy. When we talk fully factored form, we want to make sure that there are no extra factors inside our parentheses that we can factor out. We can make it more simple. We always want the lowest numbers we can. So we should get in the habit of checking these trinomials for anything common, like x's or 3's or 4's, and divide those out at the beginning. Then just focus on the easier, smaller numbers with your box method and get everything factored. Now, you might notice if we go back to this original problem up here, there are none of these that have any common factors, right? You might look at 5 and say, oh, there's a 2 and a 40 you can divide by 2, but 21 you can't divide out of 2, right? 15 and 6 you have a 3 you can divide out, but you can't divide out a 19 by 3. So there's nothing here where you're going to run into that issue, but there are other problems as they come up. So at this point, you have a few more to practice. You probably won't get through all of these, and that's totally okay. But hopefully that dividing out a greatest common factor made sense. We're going to focus more on that next class. But realistically, if you can do the box method, you can really do everything you need for this unit. The next two classes are just going to be faster ways. You don't always have to do the box. And that's really it for our unit. So keep practicing. Practice improves performance. I'm excited to watch you succeed.